Hey guys, this lesson we're going to look at the remainder theorem and the factor theorem. Specifically, we're going to look and see, we're going to talk about the remainder theorem mainly, and then we're also going to talk about how to find a polynomial if you know the zeros of it. So let's start talking about roots and zeros. Roots and zeros are also like x-intercepts. It's the function or a root or a zero. Those words are used synonymously. Makes the function equal 0. That's one of the reasons it's called a zero. So if you plug it in, you get 0. That's the answer, which means it's the same thing as being like an x-intercept. So is 2 a 0? That means it makes the function equal 0. So if you plug in 2 to the third minus 2 times 2 squared. So that's 8 minus 2 times 4. That's 8 minus 8, which is 0. So yes, it is a 0 because we plugged it in, we got 0. So it's a 0, 2 is a 0, or you can say 2 is a root. Is negative 1 a root? Well, same thing. We're going to plug in negative 1. 2 times negative 1 cubed, that's 2 times negative 1, it's negative 2. Then negative 3 times negative 1 squared, that'd be positive 1 times negative 3. And then plus 3, that equals negative 2, which is not 0, which means no, it's not a root. If it equals 0, it's a 0 or a root. If it does not equal 0, it is not. So the remainder theorem is kind of an extension of that. The remainder theorem just says that when you divide, whatever the remainder is actually the output. So the remainder is the output. It's kind of the simple way of restating that all. The remainder is the output. So we're going to divide to figure out what the output would be. So the only thing to pay attention to here is that f of a means you're plugging in a, would be for dividing by x minus a, which if you solve that out though, set it equal to 0, would be x equals a. So that's also the same thing we did in synthetic division. Is we just take the thing that we want to know, we want to plug it in, we're going to do synthetic division with it. So make sure you're not missing any coefficients here. X squared, x constant, so that's going to be 2, negative 3, and 4. And then you have to do synthetic division with the 1. So synthetic division is add, and then multiply. And then add, and then multiply. And then add. That's our remainder right there is 3, so f of 1 is 3. Which also means that if you were to divide, the remainder will be 3. So we did divide, we got 3. If you wanted to plug in 1, that's pretty easy to plug in. So that'd be 2 times 1 squared is 1, minus 3 times 1, plus 4. So that's 2 minus 3, so negative 1 plus 4, that is 3. So you can plug it in or do synthetic division, you get the same thing. The remainder is the output. So we're going to use the remainder theorem to evaluate f of 3. That just means do synthetic division with 3, and then take our coefficients. 2, negative 5, 1, negative 6. Add and multiply. Add, multiply, add, multiply, add. We get a remainder of 6. So f of 3 is 6. If you plugged in 3 throughout this whole equation, you would get 6. 3 cubed is 27, times 2 is 54. Minus, plugging in 3, 3 squared is 9, 9 times 5 is 45. plus, we're plugging in 3. So that is 9 plus 3 is 12. 12 minus 6, 6. Same thing. I think synthetic division is easier most of the time. Same idea. Remainder theorems, we're going to do remainder, divide by 2. Find the remainder. Nothing is missing. We have 3, 2, 1, and a constant. So 3, negative 4, 2, negative 5. Add and multiply. Add and multiply. Add, multiply, add. Our remainder is 7. So that's it. Remainder theorem's pretty simple. Do synthetic division, and the remainder is the output. All right, so let's talk about factors, and we'll tie it back to that very first thing we said. Is 4 a factor of 42? You should know the answer is no. Factors means it divides evenly with no remainder. So why is it not a factor? There's a remainder. What about 8 going into 80? Is 8 a factor of 80? Yes, because there's no remainder. So factor means no remainder. No remainder means it divides evenly. It also means that it's a 0 or a root, because when you plug it in, you're going to get 0. So when is a value a factor? When there's no remainder. So if we use the remainder theorem, that means that we divide, we get no remainder, which means we divide, it goes in evenly, same sort of thing. So is x minus 2 a factor? Well, x minus 2, remember if we're dividing by x minus 2, we're actually doing synthetic division with a positive 2 on the outside. Make sure you're not missing any terms. We are not. And then you can do synthetic. So add and multiply, add and multiply, add, multiply, add. That's not a 0. So is it a factor? No, not a factor. We have a remainder. Is x plus 1 a factor? That means synthetic division with negative 1. Make sure we're not missing any terms. Write your coefficients. Add, multiply, add and multiply, add and multiply, add. We got a 0. So is it a factor? Yes. All right, last little piece. These kind of tie together here. State the multiplicity. Multiplicity just means it's a repeated root. So if it has a multiplicity of 2, it means it repeated twice. If it has a multiplicity of 3, it repeated 3 times. So the multiplicity of each root. Roots, remember, we can solve by factoring, solve it all out. That's another way of getting roots. So when we solve this, we have x minus 2 twice. We would get x equals 2 twice. So this has a multiplicity of 2. X minus 4 to the 4th means you would get x equals 4 when you solve that. And you get it with a multiplicity of 4 times because of that exponent. Just tells you how many times you get the solution, how many times you get that root. State the multiplicity of each root. So we get x equals 0 first of all. Then we get x equals negative 3. And that had an exponent of 3, so that means it's a multiplicity of 3. And then this last one, solve that out, we would get x equals 6. And it had an exponent of 7, which means it has a multiplicity of 7. All right, so this last part is finding polynomials, writing them out, which means multiplying them out. So if these things are roots, it's the opposite of what we were just doing. This is review. You've done it in Algebra 2. I think we did it earlier this semester as well. X minus 1 is a root, means x, or minus 1 is a root, which means x plus 1 is a factor. Positive 4 is a root, which means x minus 4 is a factor. And then 5 is a root, which means x minus 5 is a factor. And then finding the polynomial just means multiplying it out. You can choose the order you want to multiply, it doesn't matter. Pick whichever two you want to multiply together first, and then multiply by the last one. So let's do these two first. So this would be x squared. Multiply that out, we get negative 5 and negative 4 would be negative 9x, and then positive 20. And then multiply that by the x plus 1. That would be x cubed minus 9x squared plus 20x. Distribute the x to everything. And then distribute the 1. A little trick, if you have a lot of terms here and you want to line them up, just offset them by one space. This normally works out unless you're missing powers here. So distribute the 1, we get x squared minus 9x plus 20. And then all of our like terms lined up, and we get x cubed. This is positive 1, that's negative 9, so that's negative 8x squared plus 11x plus 20. All right, another one, very similar question. We have a factor of x minus 3, and then it says negative 4 is a root with multiplicity 2, which means that happens twice. Which means if it's negative 4, that'll be x plus 4, and it happened twice. So write it out twice. Pick whichever ones you want to multiply together. I wrote a 2 instead of a 4. There we go. And multiply 2 together. So let's do these two first. That'd be x squared plus 8x plus 16 times x minus 3. Same thing, we're going to multiply this x minus 3, so distribute the x. And then we're going to offset it by one space and distribute the negative 3. (16 times 3 is 48. And then our like terms lined up, so we get x cubed plus 5x squared minus 8x minus 48. That's really about it. We've got some more examples here. So the degree of f is 5. We've got all these roots here. Degree of f is 5 means that we're just going to end up with x to the 5th. At the very end, x to the 5th will be our highest. So the number negative 5 is a root, multiplicity 3 times. So that means x plus 5 is there 3 times. And then 6 is a root with multiplicity 2. Which means x minus 6 is there twice. It's a lot of multiplying out, but we can do it. Pick any two things you want to multiply together and start with that. So let's multiply these two together, and then we'll multiply these two together also. We'll just have an extra x plus 5 at the end. So x plus 5 times x plus 5 is x squared plus 10x plus 25. And x minus 6, that's x squared minus 12x plus 36. Now we got to multiply all three of those things together. Pick any two you want. If you want to do the x plus 5 now, you can do it now, or you can save it for last. It doesn't really matter. Another way of multiplying, another trick, well, it's not really a trick, it's just a method. Maybe a system is a better way of describing it. Call it the box method or whatever you want, but if you multiply these out, you can write one polynomial across the top, and we're going to draw boxes just to organize our work a little bit. We got the other polynomial going down the side here. Just helps you organize your work. All right, so as we multiply here, we multiply x squared to each of these. So x squared times x squared times 10x, x squared times 25. And then negative 12x times all these things, so that's negative 12x to the third. 12 times 10 is 120, so negative 120. X times x would be x squared. And 25 times 12. A little multiplication trick here. 12 is 4 times 3. So we're going to split that up. So that's 25 times 4 times 3 if you think about it that way. 25 times 12 is 25 times 4 times 3. So 25 times 4 is 100. Times 3 is 300. And then 36x squared. Thirty-six times 10 is 360. And then 36 times 25. We could do that same trick a little bit. 36 is 9 times 4 times 25, so 25 times 4 times 9. That's 100 times 9, 900. All right, and we need to combine all of our like terms, and then we're actually still not even done because we still have that x plus 5. To multiply to whatever we just got. So it's x plus 5 times whatever we just got when we combine these like terms. The nice thing about this box method is like terms always go diagonal, so x to the fourth, that's the only term. Or I should say, like terms go diagonal as long as you're not missing any powers in here. So these two are like terms, that would be negative 2. And then squareds, those were all alike. 25, 36, and negative 120. 25 plus 36 is 61. And minus 120 from that would be negative 59. And if you can't do that in your head, just pull out a calculator or write it down. It doesn't really matter. More like terms right here. We've got negative 300, positive 360. That's positive 60. And then 900. And one more step of multiplying here, we have to distribute the x and the 5 and then combine those like terms. So it's going to take just a little bit more to finish this off. I showed you what I really wanted to show you there with the box method and all of that. For this one, I would just distribute the x to everything and then distribute the 5. Distributing the 5. $59 times 5. Going to use a calculator because I don't want to do that by hand. $60 times 5 would be 300. $900 times 5 would be 4,500. And then distributing the x, which I didn't do yet, we'll just change all of these degrees by 1. So that would be a 5, that would be a 4, and a 3 squared, and then this would be an x. So, a little lazy, but combine like terms now. So those combined, that's 3. These combine, that's negative 69x cubed. That should have a squared, I just didn't write it. So those combine. 60 minus 295 is a negative 235. $900 and 300, that's 1,200. And then plus 4,500. And there's our final answer. It's a lot of multiplying. The only other thing that you're really going to see besides multiplying stuff out, multiplying out 5 things is pretty hard. A lot of work, it's tedious, it's kind of annoying. The last part here, this one's a little bit easier. 4th degree, 1/2 is a root with multiplicity 2. So if 1/2 is a root, there's actually 2 ways this could go about. There could be x minus 1/2, but then this is going to stink because you have a fraction in it. A different way to say 1/2 is a root is actually 2x minus 1. Whatever that is, whatever your fraction is, the denominator just goes in front of the x. If you think about how you would solve this, you would set it equal to 0, you would add the 1, divide by 2, and that's where you get the 1/2 from. So denominator always goes in front of the x. It's just a quick way of rewriting a fraction as a factor. So multiplicity 2 means we got to write it twice. My pen is being super annoying and glitchy. And then 2x squared minus 4x minus 1 is another factor. So now we got to multiply this out. So let's multiply these two together first, and we'll multiply that answered by 2x squared minus 4x minus 1. So that's 4x squared minus 2x, so that's minus 4x, and then negative 1 and negative 1 is positive 1, and we're going to multiply by x squared minus 4x minus 1. So you can set up your box method again. You can do whatever you wanted to help you finish this one off. I'm just going to multiply it. Distribute the 4x squared to everything. Minus 4x squared. And then distribute the negative 4 to everything. And again, if you offset, your like terms will be lined up. So that would be negative 8x to the third. positive 16 x squared, and then negative 4x times negative 1. And then our last our term to distributes the 1. Again, if we offset, like terms will line up. And combine like terms. So we got 8x to the 4th minus 24x cubed. This is 18 minus 4, that's 14. That cancels out, and then minus 1, and that's it.